Hello, welcome everyone. I am Dr. Rohit Kumar, and I will be presenting the presenters today. The session is going to be mix of English and Spanish, like some could choose to present in Spanish. You can ask questions in Spanish if you feel more comfortable. I don't understand Spanish too much, so I'm talking in English. So, so this session is on effective architectures, platforms, and infrastructure. So it's going to be a technical session, and we have 3 presentations from different venues, like which will present different ideas, like cloud data warehouses, how to have smart cities kind of infrastructure, and also on how to manage architecture team. So we'll have some use cases from on there. So let me first invite the first speaker, Albert Zaragoza. So with over 15 years of experience, Albert has helped a large number of companies transform their technology roadmap by combining his deep technical expertise with proven management skills. He currently leads the engineering team on Worldsensing and previously worked as VP of engineering in everything. And he's presenting making construction sites, critical infrastructure, and cities smarter. So Albert, all yours.
Thank you, Rohit. Hi, everyone. Hola. I'm going to do it in English. I hope it's not an issue for everyone, but after the talk, you can ask the questions in Spanish. Okay, so let's go for it. So first of all, I wanted to introduce you very quickly about what Worldsensing does. We are an IoT company, as Rohit said. We are helping construction sites, cities, and critical infrastructures become smarter. So I'm hoping in this 20 minutes talk you can understand, how we do that, no, and how we actually help all these customers. In the IoT space, there's many companies. You know that IoT has been trending the same as AI and big data for a while. But basically, we've been running for a long time. So we are based in Barcelona, and you can see we are pretty much all around the world. Okay, so here a little bit of our history in the architecture and the products we've built. Okay, so if you see more or less the hype in IoT will be around 2014, 2015. So the company's been running for over 10 years now. So we started in 2008 when the IoT was not still a big thing. We build our own sensors, and that's pretty specific. Probably here you heard about, and you hear a lot of companies talking about digital products, etc. But few of them, they are on this space, which is building hardware products. So on my team, on Worldsensing's technological team, we have hardware engineers, firmware engineers that are actually building the sensors. But as we've built all these sensors among the years, we've also built software, and we help our customers focus on the data. Okay, so that's pretty specific, and as I'm going to explain to you, we are very verticalized. So there's a lot of companies that will do an IoT platform, software platform. There's many companies that will be focused on building the hardware sensors, but we focus on a problem, and then we try and fix the whole end-to-end. Okay? So that makes us very specific on the technology side for IoT. So just to give you a few examples, so our sensors are in Ponte Vecchio, for example, in this bridge, to monitor and make sure that the bridge does not fall. It's not that it's in a dangerous position, but these things were built in the 15th, 16th century, and it's quite critical. So they have our sensors there to monitor and make sure everything's fine. We are in, for example, Bogota. We are monitoring the whole city. So when you talk about smart cities, I'll try to explain a little bit how you do that. So we are monitoring the city of Bogota, which, by the way, in terms of traffic is pretty much like the worst city you can ever imagine. So forget about the issues in the rondas here in Barcelona. And basically also in construction sites like the Los Angeles Metro in the United States, they also need our sensors to improve their operations. So very quickly, what does it mean to be smart, right? Because pretty much all of you will be working on places where the data is already digital. No? So if you are interacting with a user that's inputting their data through a web, it's already digital. But IoT starts here. So IoT starts with physical signals. So you need the sensors first to start digitizing, right? So we start here we digitize the signal, we help the customers monitor what's happening. So as an example, we built for a parking sensor that's actually finding out when a car arrives to the parking spot, then you understand that the car arrived. And then once you start monitoring and having a lot of this data, then you can start predicting, acting, and engaging with the customer or the users, right? So that happens across any single use case in IoT, okay? So here is a bit more detail on the architecture for our construction and critical infrastructure. So we have, and we build these data loggers here. These data loggers are connected to sensors, geotechnical sensors that have been built, and they were built in the 1920s, for example. So these are physical sensors that you put on a mine, on a bridge, and actually they go underneath the floor, no? Underneath the earth. Basically, you connect the sensor here, and what we are doing is helping them move that data from a construction site or a remote site through using LP1 technologies, no? Like LoRa, LoRaWAN. Not sure if you are familiar with any of these technologies, but they allow us to have these sensors running for over 10 years. So you install this box there, you leave it there for 10 years, and it will be communicating data through LoRa. No? As part of our ecosystem, as we built a LoRaWAN network, we can connect any other third-party devices. So if the construction site tells us, look, we want to use your sensors to monitor our bridge, but we also have sensors, movement sensors for our workers, we can integrate that into our LoRaWAN network and then pass that data through the cloud so they can use it together. Okay? So once you move the data from the sensor to the gateway, here, by the way, here you don't have power. This is all battery powered devices. You don't have actual power in there. But once you get to this level, you get to the gateway, you have a 3G, 4G SIM card there, and then you can communicate much faster. So then you have power, and you can push the data up to the cloud, no? The cloud or the server that the customer has in-house. There's many of our customers that are still quite reluctant to use the cloud, for example. So, for example, in the mining industry, they are not very keen on sharing the data outside their premises, no? Because you have very, very critical data for them. You know if the mine is working well or if they are in risk of creating a natural disaster, for example. So once we have that, basically our team also builds the infrastructure on this side for the servers. Okay, so that means all the software we build here on this side is not. We cannot use any of the services from Amazon, Google. So we have to be pretty cloud agnostic. So that's something we have to bear in mind. And I also recommend you, once you are in a use case where you cannot run your application solely on the cloud, be careful with starting using services from a particular provider. Because once you started using the services from Amazon, Google, or Microsoft Azure, then you'll be tied in to their cloud services, and you will not be able to, for example, then take that code and put it on a customer server in-house. Okay, so that's something that we've done. Just to give you an idea, this is a typical mine and how our sensors will be placed. So you can see in there's a single gateway. So the gateway is here, up there. And you can connect all of our data loggers in ranges from 2 kilometers, 4 kilometers, and if you are in plain line of sight, 15 kilometers. So this is, just to tell you a bit about, this is quite revolutionary. Before this happened, the mines, they had to either cable the whole mine. So imagine the money and the expense that means to cable a site like this, or do manual readings. I don't know if you heard recently, there's been a few accidents in mines. There's still a lot of these very critical infrastructures and sites that are actually monitoring this manually. They send a person there every 15 days, every month, to take a reading here, to take a reading here. But with something like this, no, you install these data loggers, and then you have all your data centralized. So it's quite revolutionary. So then moving a little bit onto this is for critical infrastructures and construction. But once we started learning about that, we found out that we could do the same way we are transporting data for a sensor like this. We could be doing and creating a platform that actually ingests data from any other third-party device. Because once you understand that the parking data, the critical infrastructure data, the traffic data, they have more or less the same structure, and they are pretty much all based on time series data that actually is quite simple, then you can start bringing other data into the picture. So what we decided is to build an agnostic platform that actually ingests data from all these systems. Okay? So as you can see here, I put an example: CCTV, weather stations, vehicle counting sensors, etc. So this is where cities start to get smarter. I don't know if you've been this morning on the talk that the CTO of the Ayuntament de Barcelona was giving, that he said one of the issues that they are having is that they are very verticalized. No? They have data from the police separated from the traffic data. I mean, this is quite common. I mean, every single company, every single institution has that issue. No? They tend to operate in silos. So we thought to build something that could integrate all this data into one single point. Okay. Here a little bit, I mean, I guess you are here for technical detail. So how we build this, no? So how you go on and build a platform that's serving a particular purpose and very generic to smart cities, construction, etc. And also make it open to any type of data. So basically, we took the microservices approach. I mean, it's clear that you cannot configure a platform that will work in one way. And that's how we started. No? So we divided our layers. We saw, and we thought, look, we have our external sensor data. We will never know, I mean, which signals and which data sources a particular city or infrastructure will want to connect. And then we took it from there. So we built what we call our cost data layer, which is a middleware layer, which you can very easily configure and extract data from any API, external source, simulator, JSON. So basically, it's written in Python, and it allows us to actually build a connector to any external source very quickly. So that's how we deploy this platform. Okay, and you can see that basically, depending on the deployment you have, you can have from 1 to M connectors, no, as much as you want. Here we use Apache Thrift as well. And then to ingest that data into the core platform, you can see that here we are still dealing with the third-party devices, no? Then the connectors, and then we are getting into our core platform. So you can see that we are using RabbitMQ as our messaging service. And then basically what we have is a pipe of data that's coming into our core. So as I said, and here I put 2 examples. No? So we took a microservices approach. We have 50 Docker images in there to build our platform, but I put 2 examples. No? So here we have a domain service that's using a PostgreSQL database. That means that the data we are dealing there is quite structured. Okay, so it's very structured data. For example, this is the number or the location of all the pollution sensors that we have in Barcelona. No? So if I want to connect the pollution sensors that I have in Barcelona, I take the API of the third-party systems, I understand where they are, and then I'll pass them through my platform and store that data in Postgres. Why? Because those assets are not moving, and the data is quite stable. No? It's very structured. I understand the data quite quickly. Another example is I've gone to the external API too, and I have traffic data. This is slightly different. Traffic data is quite constant, is constantly changing, is moving, etc. So basically, I build my connector, and what do? I want to pass it to my anomaly detection service. I want to understand if the traffic at this particular time is better or worse than what happened before, no? or what is expected. So for that, we have another microservice that instead of storing the data in PostgreSQL is using InfluxDB. InfluxDB is a time series database, and we can make use of the power of the time series there to actually build our anomaly detection service, no? for traffic. We have many other services. I will not describe all of them, but basically we use Swagger for our API description and Flask for helping us with the APIs. Then all of that goes into a React front end. Okay, so we use React for our front end, and this I'll show you later on a very brief demo of what it does. No, but imagine a Google Maps that actually showing your city in real time with all the data connected. Okay. Here, basically, I've talked about the different sources, how we build connectors, our platform there. But so far here, we talk about how I show that data in real time. No? So what's happening right now? So what's happening? The pollution sensors are telling me the pollution in this part of the city is 15, now it's 20, now it's 30. So you see the levels, but this is quite real time and operational. The traffic as well. But we also, in the need of a city to become smarter, we also started building a data warehouse and a data lake service for our customers. Why? Because it's quite typical as well. So you start a project like this, a city wants to become smarter, they plug in sensors in here, they have the data in there, but at the end of the day, most of the times they don't know what to do with the data. So they know they want to store it, they want to understand what's happening, but they are not ready yet to build all the use cases or to have all the reporting mechanisms that they will have to build in the future. So for that, we also build a data warehouse and data lake system. By the way, and on top of that, obviously, once you have all that data, then you can build all these different applications. No? So what we call the city insights is the real time. The city analytics is something that provides you extra information on the data you've been ingesting. And the reporting is what I'm talking to you right now. I want to have a full report of how the traffic went on from the last week. No, I'm not interested on right now, but tell me how it went for the last week. So that's the additional applications that you can build on a platform like that. Okay. So if we move a bit more into how we build this data lake architecture, so we have the same issue. We don't know what type of data is going to come in, and we don't know what we are going to be storing. No? So basically, we use something, and I don't know if you know it, but it's something called Kafka Connect. It's an open source project that actually has a lot of predefined connectors with external sources. No? So basically, if the city tells us, look, I don't have any sensors, but they have an historic database of the traffic for the last 20 years. No? So, but they have it stored in Oracle SQL. Most probably, Kafka Connect will have already a connector built, so you can use it and then ingest it onto your own infrastructure. Then the most famous Apache Kafka, no, for our broker. And then at the end of the day, you pull in any particular database. So depending on the project, we use PostgreSQL because it's enough. You can then go onto bigger things, no, and go into Hadoop clusters and bigger things. But basically, it's also the same approach. It's something that you can build layer by layer and then decide where you want to store your data. And that's something we do based on the customer and on this problem we are solving. Okay? And pretty much the same for the BI. No? So once you have your data in the data lake, you also will have to go and analyze that data somehow. So we are using tools like Pentaho Data Integration for the ETL process and Metabase to another open source project for building the analytics. So at the end with this, you build real BI mechanisms for people then to analyze them. No? So for the end customers. This is an example. So I've been talking a little bit about the architecture, but I wanted to show you where these things are used. So maybe you don't know, but all of the cities have these control centers where they have different departments monitoring and checking what's happening, no? in real time, or analyzing the issues that have happened. So on one side, you will have things like cameras, then probably a higher side view of the city. But then you have our platform, no? Something like our platform. And it's actually is what I mentioned before. No? It's almost like a Google Maps, but in real time, knowing exactly what's happening. Have 2 minutes. So basically, that's how it works, no? And how these tools are used. I have here a very quick demo. I'm not sure if the video should I do. Does it play or? Yeah. So I wanted to show you very briefly. So can you see here? This is Barcelona. Here we've actually clicked on travel time. So here we have traffic data. In this case, from the rondas in Barcelona. You can actually see the whole speed range of the city. You can see that you could have this data from Google, no? So Google traffic, but you don't have this type of analysis, no? Like by quarter and where my assets are located. So in here we are cross-referencing that data with where my police patrols are. So you can here see, no? I have 5 patrols and I was expecting 5. I have 10 and I was expecting more. No? So you have a lot of data that the operators can use to react faster to events, no? And to prepare themselves to respond to issues. You can, from there, interact with the VMS sign variables. You can check the pollution services. So this is a little bit what I mentioned before. It's trying to pull all the data together and making you, and allowing you react faster, no? to issues. So that's pretty much what the platform does. And that's it, I think. If I click next. And that's it. Basically, when people talk about smart cities, smart projects, smart infrastructures, at the end of the day, it's not more than that. It's trying to visualize and have all your data in one place and try to make decisions better. So that's it. That's what I wanted to tell you today, and hope it was interesting. Thank you. Cheers. Any questions?
My question is about real time, which
Yes.
is the maximum frequency or minimum latency that you have achieved.
It depends on probably it depends more on the external systems than on our platform. Our platform operates in the milliseconds space, but it's normally the systems that take longer to send us the data. For example, when you are dealing with pollution data, you don't need the sample every millisecond. So you have samples every 30 seconds, 1 minute. No? In the traffic space, yes, it's constant. No? It's constant. The pipe of data is really real time. No? It's arriving constantly. But actually, once you start analyzing it and getting to the average speed ratios, etc., we set thresholds. Now we say, okay, we are going to tell you the average speed every minute. You don't need to know it in real time. No? So at the end of the day, the platform is prepared, but it's more about what's actually needed for the use case. So. Mm-hmm.
Yeah, well, my question was addressed if you are prepared for having sensors, for example, in drones or in cars that you need a quick reaction. Instantly reaction.
As soon as you can build an integration between the data that the drone is sending with the platform is ready. So it's always about how fast the drone system can send the data to us. So yeah.
Okay. Mm-hmm. Thank you.
¿Hay alguien ahí? Sí.
Hi, Albert. This is more, it's not data related, but it's about, again, about communications. Thinking about LoRaWAN, for instance, it's a wide area network communication, I guess, and also Sigfox, for instance.
Yeah.
So systems that can communicate very long distance with small bandwidth, okay, where some bytes per second or bits per second.
Yeah.
And but the good advantage is a parallel network. I mean parallel respect mobile networks or okay.
Mm-hmm.
And I guess that if it's possible to build a new communication system with a very private channel, that because I don't think that the LoRaWAN and Sigfox operators are obliged to keep the user data, like usual mobile operators, for instance.
Mm-hmm.
And I'm thinking if it is possible to build a channel like an SMS, very private channel to communicate to all the population. For instance, think that you can send an alert to all people, or maybe to all the people in a special area, because it's some emergency in the area or something like this.
I mean,
the idea is consider the people like IoT devices.
Thank you. There are a few things, no, on your question. So one of them is you mentioned Sigfox and LoRa. They are providers, no, connectivity providers. They are actually not. Sigfox is a provider. Sigfox is a company that puts the networks for you, and you can use them, but you have to send the data through them. How we use LoRa is we do our own network. So basically, LoRa is a protocol that you can use to implement your own networks. So basically, on that end, I mean, can you build something to communicate? I mean, we've used LoRa to build a network for our customers. No? So that's different. And then with regards to sending a message when there's an alert, there are cities already using that. So in the States, and I think that's more up to local regulations and what you can actually do and how you can interact with a phone that's mine, that's yours. But in the States, they have some laws where they are allowed to do that. And basically, they can overtake all the network, like the 3G, 4G networks, and actually send an SMS to the phones when there's a real emergency. So I know there are ways to do that, and some people and some organizations are using it already. Yeah. Like in a... I believe you can do it, but then you need the infrastructure and the resources to build a network to then be able to interact with that. Yeah.
Yes. One question, very short question. Previously, you said that some companies have their data lakes in-house because it's very compromised information. Is it the same with all the local governments like Barcelona or all the cities? Do they have their data lakes always in-house, or how does it work?
Well, at least as far as all the cities I know, what happened is that they invested in data centers a while ago, like 10, 15 years before the wave of public clouds appeared, the Amazon Web Services, Google Cloud. They actually invested a lot on their own data centers. So somehow, I'm not sure if they are geared towards using their own data centers because they did an investment and they have to use it. It's kind of political reasons, or because they are scared of going to the cloud and sharing the data out of their control. But it's happening. Most of them are using their own data centers. So I know Barcelona has their own data centers. That doesn't mean they don't use the cloud as well for some other things. But in general, they are geared towards using their own infrastructure.
So let's thank the speaker again. Thanks, everyone.
Thank you.